let us start with this recurrence relation. Okay, before starting, I would like to ask you, can you find out like similarity in this one and the previous video? I'll pause for 2 seconds. Okay, can you spot the difference? Well, I'm not Dora and I'm not going to make you wait. So the thing that is different over here is the previous video we had a C over here, which means it was a constant. And here in this equation, we have an N, which is a variable. So of course, the time complexity will be different. But you can see this part remains the same. So solving this part won't be such a headache for us, right? Okay, so let us proceed. So let us start as we do. T equals to T of n by 2 plus n. Now we are going to do some rough work over here. Here equals to T of n by 2 plus n. And as I have already told you what n by 2 means, it means that n is decreasing. N is getting halved every time, in every step actually. So it is T of n, then it becomes T of n by 2 by 2, which means n by 4. Then it becomes n by 8, and so on. Okay. So now, once this is clear, let us see. Now we need to find out this one. So T of n by 2. Now when it was T of n, it was T of n by 2. So when it is T of n by 2, see 2 will remain the same because it's a constant. So 2 T of n by 2 by 2, which means 4. Plus this n. In the previous video you have seen, we have kept the C as it is because there is no change because it's a constant. But here the n will change because if it was T of n, then it remained as n. Now if it is T of n by 2, what will it be? Of course, T of n by 2. Yeah. So let us substitute this one. So I'm writing the 2 here. Then the third bracket, I'll write 2 T of n by 4 plus n by 2. Bracket close. Okay, let's simplify this. 2 into 2, 4. T of n by 4 plus. Okay, now 2 multiplied by 1 by 2 means 1. So it's n plus n, which is 4T of n by 4 plus 2n. Okay. Now, let me do one thing. Let's simplify this from the beginning, okay? As we have it as n by 2, so let's have all the terms in the term of 2. So can we write 4 as 2 to the power 2? 3, of course, then. So 2 to the power 2, T of n by 2 to the power 2 plus 2n. It remains as it is. Now we will solve for 2t of n by 4, which is 2 multiplied by n by 8 plus n by 4. So the same thing, 2 to the power 2, 2t n by 8 plus. Okay, let's do one thing now. We'll just simplify this one also as 2 to the power 2. Yeah, if this is this, then this will be, yeah, plus n by 2 to the power 2. So let me write it. 2 to the power 3 plus n by 2 to the power 2 plus 2n. I'll simplify that in the next page. N equals to 2 to the power 2 equals, right? 2t n by 2 to the power 3 plus n by 2 to the power 3 plus, what was it? 2n. That's 2n. Okay. Now we are going to simplify this into this, means 2 to the power 3. You see? Okay, I'm leaving no point of confusion because you can see the channel name. Yeah, we simplify it to infinity. No point of confusion. Even if you have a confusion, comment it down and I'll solve it. Okay, so it's 2 to the power 3 t of n by 2 to the power 3 plus, now this and this cancels each other. We have only an n and we have this 2n. So now if we simplify this further, this becomes this. And if we go on doing this, we'll get a general equation, which is 2 to the power k t of n by 2 to the power k plus, now this are same. So this will be k into n. Simple. Now we just need to find the time complexity. That is what is left. Okay. Oh, wait. Yeah. Interesting. Okay. So what was our base case? It was t of 1 equals to 1. So we'll replace the whole thing like this one with this. N by 2 to the power k equals to 1. Which means n equals to 2 to the power k, taking log on both sides. Remember, it is log base 2. I'm not writing it because I've already told you in the previous video. Now, even if you want, I'll do, okay, log base 2, n equals to log base 2 to the power k. Now, we have log base 2 n equals to, this means 1, this will go here. Okay, for you, I'll just simplify it. No point of confusion. I'm going to leave, okay? Log of base 2 n equals to k into 1. So the thing is, we are going to replace this. Now this means what? This means n. So we'll write n. What is this? T of, yeah. So we are going to, okay, let's not consider this as 1. We can consider this as c also. Okay? It's a constant. Not always 1, it can be c. Okay? C is a constant. So we are going to multiply this as c. I'm going to change this over here also. Yeah, make it c. Constant. Let's be on the safe side. Plus k. What is k? K is log base 2. Now we don't have to write log n. Okay. Next page we have t equals to n dot c plus n log n. Now we are going to take this and our time complexity will be n log n. And you know which algorithm uses this? Comment it out. I know you will because you are studying hard for yourself. So do the homework for yourself. And if you do a mistake, I'll correct it. Okay, so yeah, your homework is which algo. Okay, let me write with them. No point of confusion. Which algorithm uses this time complexity? Not uses, has. Yeah. This is the time complexity we have found of the recurrence relation. Now I have one more homework, which is going to be really interesting. Rather than just finding out the name and commenting it, which is also important, but this is more important. Yeah, try this out. Can you spot the difference over here? Of course, the n remains the same, and we have just changed this to from this to this. But one more thing, we have already done this too. So now from the previous videos, if you want, you can take the help and you can solve this Let it be seen. Okay. And comment the answer. Okay. Thank you for watching. Please support and like and subscribe and share with your friends.